Okay, so coming back to the slideshow then, I don't remember if we did this one, did we? No. Oh, we haven't done anything. Okay, so let's talk about this one. We've got a couple goals here. One is we need to find the value of x, and the other thing is we need to find the measure of angle 4. Which one do you want to do first?
Measure of angle 4.
Measure of angle 4. You want to jump right to that?
Yeah.
All right, how big is angle 4, Smarty Pants?
125 degrees.
Why?
It's corresponding to 125 degrees on the left.
Beautiful. Upper left, upper left. The lines are parallel, so therefore angle 4 has to be 125 degrees because they're corresponding angles. And again, the theorem was whoops, get rid of that. Get rid of that. Parallel lines implies the corresponding angles are congruent. Okay. We'll then do the algebra and then check to see if the algebra matches with what we already know angle 4 is supposed to be. So going back to the 4 steps for solving the problems Gesundheit that I gave you yesterday. Number 1, figure out what pair of angles you're talking about. So let's look at this angle and this angle. What's the relationship between those two angles? What kind of angles are they, Ashley? Correct. Why? Which pair of angles are they? Wait, hold on. Let's continue with that. So if they're supplementary, what am I going to do with their measures? Perfect. Okay, so we're going to do 125 plus 2x plus 15 is equal to 180. Now back to the other question. Why are they supplementary? Which pair of angles of the 10 that we've talked about are those two? Should we break it down? I'm not going to start rapping or anything. Okay. Are the angles on the same side or the opposite side of the transversal? So you said opposite, same, I don't know. Which of those three would you like to go with? Hold on, let's back up. Which one's the transversal? Line A, line B, or line C? A, the horizontal one. Okay. So are those two angles on the same side or opposite sides of the transversal?
Oh, same.
Same. So that means they're either corresponding or they're consecutive blah, blah, blah. And we'll deal with the blah, blah, blah later. Are they corresponding?
No.
No, because that one's in the upper left, this is in the upper right, can't be corresponding, so now they're consecutive. Which consecutive? Interior or exterior? Are they between the parallel lines or outside? Beautiful. So therefore, these lines would be parallel lines. Ooh, the red looks cool on the black. Implies that CEA sub. Sub. Okay, good. So we identified the pairs of angles, we wrote an equation, we solved for x. X is 20, ¿sí? ¿Sí? Bueno. Now what? Well, we already did angle 4. It wants to know the value of x and the measure of angle 4. We already found angle 4, but let's check. Question?
No.
Answer. Do.
So you would plug in x and 2x plus 15.
Okay, I'd get 55.
So that would be the measure of that angle.
Mm-hmm. Wait, I'm iffy on that angle. What angle is that angle? I hate pronouns. Hate's a strong word. I dislike pronouns. How does this confirm? I didn't write it down. How does this information confirm that angle 4 is 1?
Because if you subtract 55 from 180, it would be the measure of angle 4.
Beautiful. So it does confirm what we already knew, that angle's 125 degrees. Okay? We good with that?
Yeah.
Let's move on to the next one then. Oh, look, we got it right. Yay! Okay. Next one. It ramps up quite a bit. We still have the two parallel lines cut by a transversal. Which one's the transversal? Is it obvious? Should I even ask that question? No, it's not obvious, or no, I shouldn't ask the question?
It is obvious.
It is obvious I should not ask the question. Is Paul speaking for everyone?
Yes.
Okay, beautiful. Okay, so this one gets a little weird. Ideally, we'd like to match up the same variables. So I'd like to match up the x with the x and then deal with the y later. Otherwise, we get a system and that goes the whole place we don't want to go. So we want to talk about this angle and that angle. What's the relationship between those two angles, Nicole?
They're supplementary.
They're supplementary. So again, 9x, ooh, that looks pretty. 9x plus 12 plus 3x equals 180. Why? What pair of angles are those? Excellent. Good answer. It isn't any of the pairs of angles we've talked about. Those aren't alternate interior, they're not alternate exterior, they're not consecutive, they're not corresponding. So the question is, how did you know to set them, how did you know to say that they're supplementary?
Because the angle with 9x plus 12, its corresponding angle is right next to 3x.
This one?
Yeah.
Yeah.
And so because they're adjacent and they're like next to each other, they equal 180.
Beautiful. Remember what we talked about yesterday? When we have this scenario of two parallel lines cut with a transversal, you pick any two angles at random. They either have to be congruent or they have to be supplementary. There's no other choices. So this one is a small acute angle. This is a big honking obtuse angle. That indicates that you would do this. Okay, so solve that. I need some help there.
14.
14 exactly? Awesome. Okay. Now, how do I find y? Oh,
You gotta plug in x to 9x plus 12
I gotta plug it in there.
into x.
I have to plug it in here.
Yeah.
What about here?
No, you don't really.
I can't plug it in here?
You can if you.
I can, because this is America.
Yeah.
If I power right on. But you're suggesting I plug it in up here.
Yes.
This, however, requires I only take 14 times 3, which I can do in my head. This, however, requires that I do 14 times 9 and add 12, which I can also do in my head.
Go for it. Go for 3x.
What'd you call me?
I said go for it.
Oh, I thought you called me a gopher. You want to do which one?
3x.
3x, you sure?
Sure.
3 times 14 is
That is 42.
42. All right, so what does that tell me about 4y minus 10? Go ahead.
4y plus 32 equals 180.
32.
I'm sorry?
4y plus 30, because negative 10 plus 42 is.
Oh yeah, well let's go back to the start here. Let's not
All right.
skip steps. 4y minus 10
Plus 30, plus 42
plus 42
equals 180.
equals 180, because those are a linear pair. So 4y, that's 32 from the other side is 148. I do my math right? So y is equal to 74.37.
Yep.
Hot diggity. If you wanted to check to make sure that's good, then you could plug in y at the bottom and make sure all the angles work out. Like for instance, if I plug 14 in here, 9 times 14 is 126, I believe, which would give me 138, and oh, look at that. 138 plus 42 is in fact 180. Question?
For like the words, like for the problem, it says find x and a measure of angle 3. Which one is angle 3?
That's a great question. I didn't even read the directions. Which one would you like to make angle 3? Here, angle 3. Done. You know, once we get one of them, then we can just, you know, because now we have 42 and 138. Everything is going to be either 42 or 138, so we're good. Okay, questions on that one? So we learned that if you want to match up the variables, then you sometimes have to work with angles that aren't one of the pairs we've talked about. That's not the only way to do the problem. You could have set up a system by saying that 9x plus 12 is equal to 4y minus 10, and 4y minus 10 plus 3x is equal to 180, but we don't want to go there yet. We're not ready for systems, are we? Question?
For when it says state zeros, would you say like linear pairs and stuff like that?
Well, that's another breakdown in this case, is we don't have a theorem that allows us to relate this to that. So I would use, right. Everybody know that one, right?
Yeah.
Okay, good. Anybody not? Good. Die Feisse sneaks. That's German for I don't know. Hey, look, we got the right answers. Woohoo! Next one. Let's do this one in green. It's your favorite color?
That is my favorite.
Thank you for sharing. Hey, everybody, green's Paul's favorite color. Who else likes green? Nice. Blue fans out there?
Yeah.
Uh-huh. Yellow?
No.
Red. Orange.
What?
Black. Uh-huh. Pink. Thank you. Pink. Yeah, good call. Pink. White.
Gold.
Purple. Forgot purple. Good, good. Teal. Nice. Nailed that one. What am I forgetting? Chartreuse. Orange.
Turquoise.
Turquoise.
You copied what I just said.
Any color that didn't get named that's your favorite color? So we got it all? Good, good, good. Let's move on. We're going to use green. Okay, so we're going to look at that angle and that angle. Step one. What kind of angles are those, Jack?
Alternate interior angles.
Beautiful. And what do you know, Jack, about alternate interior angles?
They equal each other.
Beautiful. So up here, because it looks cool in the black, parallel lines implies AIA are congruent. Good start, Jack. What equation would I set up?
X squared equals 2x plus 63.
Outstanding. Ooh, quadratic. How many answers? Two. Both might work. Both might not work. What do I do next, Jack?
You subtract x squared, or 2x minus.
I like to keep a positive coefficient on the squared term, so we'll move everything over here with the x squared. Whoops, 63 equals 0. See? What next?
You find two numbers that multiply to negative 63 and add a negative 2.
Any idea what those two numbers would be?
No.
Michael?
9 and 7.
9 and 7. So negative 9 or positive 9?
The x minus 9, x minus 7.
X
Or
minus
7.
9, x plus 7, and therefore x is equal to 9 and negative 7. What do we do next? Check them. I'm feeling good about the 9, so let's check the 9 first. If I plug 9 in here, I get 81. That's okay, not a negative angle measure, I can go with that. However, I need to check the other angle to make sure it matches. 2 times 9 is 18. 18 plus 63 is in fact 81. Woohoo! Check. What about negative 7? Well, what's negative 7 squared? 49. 2 times negative 7 is? Negative 14 plus 63. 49. Woohoo! 2 answers, both work. And again, don't exclude the negative answer just because it's negative. The only time sorry, I lost the ability to speak in that moment. The only time it becomes a problem is when you plug it back in and you get a negative angle measure or the angles don't match. Most of the time the indicator will be that you get a negative angle. So that answer gets thrown out. But in this case, both answers work. Okay. How are we doing so far? Is this helping a little bit?
Yes.
Good. That was the plan. Next on the agenda. Oh, look, there's our answers. Woohoo! Oh, we didn't plug it back in.
I got 130.
Thank you. Did you get 99 also? Because you should have gotten 2 answers. You did? You didn't. You liar. All right. This one showed up on the homework, and some of you were freaking out about it.
Yeah.
This is what's called a crook problem. A crook. C-R-O-O-K. Not crook like a bandit, but crook like a shepherd's crook. You know what shepherd's crook is?
Yes.
Those big curved sticks that they use, that a shepherd uses when they're sheeping.
They're sheeping, okay. Because that's a bird.
Sheeping? I'm almost sure it's a verb. Who's got their iPad handy? Look up sheeping. Go to dictionary.com, look up sheeping.
Alright.
The act of sheeping. I'd like to go to the movies tonight, but I have to go sheeping. How come you didn't go to the game? I was busy sheeping.
Wait, I spelled it wrong.
I don't know what past tense would be though. Shept? Sheeped?
I don't think it's a word. It's not a word.
It is a word. It is a word. Sheeping.
Hang on.
I will sheep. I am sheeping. I have shept. I'm pretty sure that's, you must be on the wrong site. Are you on dictionary.org or something?
No.
Dictionary.com? Because it'll even tell you how to pronounce the word. There's a little button you press, it'll say sheeping.
There's no such thing as sheeping. Sorry.
That hurts. Okay. The reason it's called a crook problem is because you've got this line that's not a line. It's bent. It's bent like a crook. The secret for this is what it says up here is drawing an auxiliary line. One of the things that we can do in geometry is we can add lines as we need them as long as we don't make too many stipulations on the line. So I'm going to slap an auxiliary line in there using my fancy smartboard techniques. Watch carefully. But no, just watch. Whoopsh. One person was impressed. Great. I'm putting in an auxiliary line through the crook. And I'm making a stipulation that that auxiliary line is going to be parallel to all the others. So now I have 3 parallel lines.
How does that? I see.
What's that?
Then you have the one side of the line that transfers.
You go. Come on. Talk me through it.
You have the 2 lines that it's really hard to explain.
You want to draw? Why, you afraid of the smartboard? You have a fear of smartboards?
Yeah. I don't know how to draw.
I don't know. Talk us through the problem. Tell us how big angle 1 is. If you don't want to, you don't have to. You can just sit there and miss the opportunity to teach us. You don't know how to solve it? Okay. So notice what the auxiliary line did is it split angle 1 into 2 parts. Now notice I said 2 parts, not equal parts. It's not bisecting the angle. The most common mistake with auxiliary lines is people think, oh, now those are split in half. And so if I find one, I just double it. Can't do that. So let's start with this. How big is that angle? Oh, that sounded really intelligent. Nah. Put your hand out. How big is that angle? Megan?
Well, 180 minus 44.
Which is?
30.
See that black thing on the desk in front of you? Don't be bashful. There you go. I've never seen anybody sarcastically press the buttons on a calculator. 36. Okay, important question though. What kind of angles are these 2? Which pair? Nope, not linear. More so than supplementary. They are supplementary, not complementary. You said complementary, right? They're not complementary. Go ahead.
Is it a linear pair?
No, because they don't share the same vertex. Stop talking, Paul.
Is he right?
I don't know. I didn't hear what he said. Vanessa.
Consecutive interior.
They're consecutive interior angles. Very good.
Active.
How big is this angle?
118.
Why 118?
Because if you subtract 180 if you subtract 180 by 62, you get 118.
Yes and no. This angle would be 118, but I'm looking at that angle.
Ooh.
No? Megan, you started this mess. 62. Why? What kind of angles are these 2?
Alternate 2.
Good, alternate interior angles. Okay? Therefore, how big is angle 1? Becca?
98 degrees.
How'd you get that?
I added 62 and 36.
Good, 62 plus 36 gives us 98 degrees. Okay? Let's suppose you have a crook problem that has more than one crook in it.
Oh.
I shouldn't say more than one crook. A crook with more than one bend in it. Let's say it does something like this.
Oh, no.
It's fine, it's doable. You just draw in 2 auxiliary lines and then work from the bottom up and from the top down, using these ideas of either being supplementary or complementary. Notice you treat the top half and the bottom half like separate problems. So maybe it helps to cover this up, and I know I'm not really covering it up, it's just shining on my shirt. But if you cover it up on your paper and you solve this part of the problem where you just look at the angles you have there, get that angle measure, then cover up the top part and solve this because they're considered 2 separate parts. When you look at that crook problem that I just drew, when you've got 2 crooks, then you just have 2 auxiliary lines. Now I got 4 different things to solve for. But eventually you can work yourself up to the angle you're looking for. And the problems will change based on what given information you start with. So I might start a problem like this where I give these inside angles. I might start with this angle and ask you to and give you another angle and ask you to find the angle down here. So there's all kinds of different things that the crook problem can ask you for. The trick is recognizing the auxiliary line that comes through there. Okay, and you can draw those in willy-nilly as long as you draw it in parallel to the other 2. Okay, and that's also an important key that it's got to be parallel. Okay, that's the wrong day number. Should be day 4. All right, so that should help with the homework from last night, yes? Okay, so the difficulty that a lot of you had was 2 things. Number 1, never seeing a problem like the crook problem. And number 2, knowing how to apply the procedure that we talked about yesterday. Okay? Beautiful. Let's stay with notes then while we have them. Let me stop.